It was the first block day after we started putting a point on a line, or locating a point on a line is probably a better way to say it, using weighted averages. So we did that really quickly after the little mini quiz yesterday. We started the lesson. I'm going to go back through the very beginning, what we did yesterday, super fast. This is kind of like part 2 to what we did today in class. So this would be related to the video that says Mr. Gill Geo August 21st, 22nd. And that one I'm going to label part 2, what we did in class. I'm sorry, part 1, what we did in class. And this is like part 2 because we just had to rush through stuff so much at the end. I'm going to go a little slower and also answer some of the questions that you guys crumpled up and threw up to the front of the room. I don't remember a ton of them and I didn't bring them home, but I can at least get 2 or 3 probably in. So with that in mind, first, you have 2 assignments from weighted averages. There are no IXLs. This is your weighted averages assignment out of the book. And then I gave you a worksheet, which is exactly like what I just circled in yellow. And you're also doing 1 through 8 on that worksheet. This down below we haven't gotten to yet. I don't believe we've gotten to it. I'm actually not sure what that was. If that was the segment addition or if that was partitioning a line segment using ratios. Either way, don't worry about the bottom. Just what is circled is your assignment so far after locating a point using weighted averages. And then again, the worksheet with the 1-page worksheet I handed out. There's also another worksheet that I handed out, which has midpoint problems on it. You're supposed to do 13 through 15 for midpoints. It's the same worksheet that you did 3 through 6 for 3 through 6 for what was it? Oh, the segment addition, like little plus little equals big. I may do another video where I go over all of the answers, so I'm not going to worry too much about those right now. All right, so first day we went over this bell work. We talked about what an average was. Super fast. An average, if everything is weighted the same, everything is the same importance. I'm actually going to do it straight from a line segment. I'm not going to even go over that. We said if we had a line segment and we wanted to locate a point on this line segment based on 50 and 100, these 2 values being weighted the same, it's just figuring out an average. That's all. If they're weighted equally, you're just figuring a normal average out. Neither 50 nor 100 is more important than the other one. So if we did just the normal average calculation, hold on, I'm gonna have to flip that. There we go. The normal average calculation is you take all of your values, in this case it's just 2, you add them together, and then you divide by the number of values. So 50 plus 100 divided by 2, we did this in class, 75. So we said 75 represents the average, but to take that a little farther, we also said 75 represents the midpoint. It is exactly in the middle between 50 and 100. So this line segment on the right, that line segment there, would be the exact same length. Let's do that color as that line segment right there. It worked perfectly, so let's finish it off. Those would be the same length. That's the definition of midpoint. So again, that would also be a length of 25 from A to the midpoint. You could call it C. We've already done it. It's already recorded. I'm not going to keep going over it. So here's where it got different. We said, well, if we do weighted averages, all that means is one of the points, or maybe more than one of the points, if you have more than 2 points, is more important than the other point, or points plural if it's more than 2. So in this, we said, all right, well, what if we had these 2 values for A and B, but point A is now weighted 3 times more than B? I'm going to do the simple version. because we've already done the full version in class. Hold that thought. There we go. So the simple version is, well, if it says 3 times as much as B, then A has a weight of 3. It says pretty much 3 right there. I want you to write the W in there. That stands for weight. So the weight of A equals 3. If you look over here on the side, it's the same equivalent of saying if A is 3 times as important, 3 times is important. I'm not going to use any other words. It's just like having 3 60s. If it's 3 times more important, it's like having 3 values of 60 versus 1 value of B, which is 100. If they don't mention the weight, we said then it's got to be 1. Again, if you look over here where I underlined, that's because we only have one 100 that we're going to use. We're going to use 3 60s, one 100. Now we just kind of do a normal average and we add all of these together. And in class, we said 60 times 3 equals 180. 100 times 1 equals 100. Now we said, okay, we got to add those together because we're averaging. So we got to see what our total number of, like what our total is across all these 60s and the 100. And then the last thing was we divide by the total number of values, which is now 4, because again, we're treating this as if 60 was 3 times as important, which means it's like we have 3 of them. So that's why I divided by 4. And we said, first of all, the midpoint would be 80, because that's right in between 160. And we also estimated, I'm going to do more of this in a later, well, actually, I don't do more of this. It's in the other video. So here's one of the questions that came up in class. Kids said, well, why did you keep figuring out the midpoint? Why are you showing us that right there? This is not about midpoints. I just want you to understand how to estimate a value when you see 1 point is weighted more. And the only way to really estimate is you have to start with the midpoint. You have to figure out what that would be first. So you don't need to do this part right there. I'm just doing it so that you understand how to estimate, because that is a question on the quiz. Plus, that helps you know whether or not your final answer is right. Like it'll keep you from maybe making a math mistake. So if I know the midpoint would normally be 80 if A and B were equally as important, weighted the same. If A is more important, which it is, it's got a weight of 3. That means it is more important, quite a bit more important. We said then the normal average won't be the same. It'll change. The average won't be 80. It's going to move toward the point that is more important. That is a huge concept for the quiz and just in general in weights. The more important weight pulls the average in that direction. And we said, well, 3 times would probably put it somewhere in there. If it was 10 times, if A was 10 times the weight, it'd probably be all the way almost out at 60 somewhere, like somewhere in there. But if it's only 3 times, and if it was only 2 times, it'd probably be a lot closer to 80. But if it's 3 times, it would move somewhere where that red circle is approximately. And sure enough, if we do the math, 280 divided by 4 is 70. So it will be 70. All right, so that's quick review. We then came up with a formula. This was kind of the last piece. If you are totally lost, this is what you need to be able to do. If the weight is 3 times as much, that means the weight is 3. We sort of already did that. We said if it doesn't mention the weight for a point, like it doesn't say anything about the weight of B, then the weight has to be 1. Now, if it said B is weighted 2 and A is weighted 3, you would just use those 2, but it doesn't say that in this problem. It doesn't mention anything about B. So that's our 2 weights. I got to manually erase, so hold on. All right. Now we said our next step. So kind of like, if you think back over here, kind of like, something's wrong with my screen. Kind of like what I did over there. We said, okay, well, the first thing I did is I added all three of the 60s together, but adding 63 times is the same as multiplying 3 times 60. So just like we did over there, we're going to wind up multiplying as our first step. So I want you to actually circle the values. A lot of kids were not doing this and they didn't know what to do. If I give you a process and you're struggling, follow the process. Like it drives me crazy when I tell you exactly what process to use and I come over to you and you're not using it. They had it in their notes. If you need to, when you're taking notes, say step one. This is step one. I don't always write that, but tell yourself if you're not going to remember it. So step one was write the weights. So where you see W equals 3, W equals 1, that is step one. Write the weights below the points. Step two, circle the weight and the values. I circled 3 and 60. I circled 1 and 100. The third step, and if you circle it, hopefully this will kind of start to trigger your memory of what you need to do after you circle. I need to multiply the values inside each circle. So I'm going to multiply 60 times 3. So that's 60 times 3. That gives me 180. I'm going to multiply 100 times 1. That gives me 100. I'm just going to kind of drop down and say 100. The next step, just like we did again over here, I added those together. I added the 360s, which was 180, plus the 100. I'm going to add those together. That gives me 280. Again, same thing I got over there. And then the last step, and I'm going to rewrite this as a whole formula. I kind of doing it in reverse order of what I did in class. We said, well, I need to divide by the weights. I said in class, the sum of the weights. You don't understand what that means. It means the weights added together, all the weights. In this case, there's only 2. You might have 3 weights. You might have 4 weights, and I'll show you that in a minute. So if I add the weights together, I'm adding the 3 and the 1. Again, those come from that 3 and that 1. Those are the weights. And again, I get 280 divided by 4, so I get the same answer, 70. So now I'm just going to write the exact formula. Third time, you're doing the same thing. Step 1, write the weights. You have to get this, by the way, from the problem itself. You would not know the weights if they didn't tell it to you. Well, unless they don't say anything and it's 1. But you wouldn't know A is weighted 3 unless they tell you that. There's no way to know that other than them telling. I'm going to circle that, which is going to tell me to multiply. Once I do that, I'm going to add them together. And then the last step, and I'm going to write divide by the sum of the weights. But if you need to just write add the weights together, divide by the weights added together, then you can do that. By divide by the sum divide by the sum of the weights. And I already did it just a second before. If you need to go back and watch me do it again, you can go watch. So that's the formula visually. There is a formula in the book. I am not going to teach that formula. It's got a bunch of W1, X1, W2, all this kind of stuff. I don't know that you'll remember that. I hope this visual version is better, but if you want to just look at the book, you do not get that formula on the EOC. So you would have to memorize it all the way through the year, and we're not going to really see this again. I don't even know if we'll get a chance to review it before the EOC, right during the last week or two before the EOC. All right. Let's see. I really can't think of any other questions from this lesson that people threw up to the front. Most people said they were good, or if they weren't good, they didn't really have a question. They just said they needed help. The only one I can really remember was that one about the midpoint. So now I'm going to move on to the next piece of this. I think it's the next. Yeah, here we go. So now sometimes you are going to have 3 points that you're going to be doing a weighted average for. instead of just 2 points. So again, here's an example. It's weighted 3 times as much as point C, 4 times as much as point A. So pretty straightforward. If B is weighted 3 times as much, then it's 3. Just use the number they give you. If they would have just said a weight for each number or for each point, you'd use that weight. C is 4 times as much as A. So it's 4. And then A doesn't get mentioned, so we know it's 1. Now I do the same exact thing I did on the other one. I just have 3 different circles that I'm going to use to multiply and then add. So again, multiply what's in there, multiply what's in there, multiply what's in there. I then add all of that together, and I'll divide by the weights added together, 1 plus 3 plus 4. So I'm just going to do a quick version of that. Hopefully you can follow where I get this math from. 60 times 1 is 60, plus 70 times 3 is 210, plus 4 times 100 is 400, divided by all of the weights added together, which is 1 plus 3 plus 4. So what's that? 610, 670 on the top, 8 on the bottom. I don't have a calculator, but I'm just going to do quick math. 8 goes into 64 8 times. It goes into 30 3 times. So where can I write this? Um, let me just get rid of this. So it would be still not going to be able. So here, I'm just going to go over to this side. It would be 30. I'm sorry, 83. And what would I have left over? 2, I believe it was, right? 430, yeah. 2, no, that's not right. 6. So 6/8 is 0.75, I think. And that kind of makes sense. We know 100 was the most important. 70 was definitely gonna pull it a little bit. It's harder to visually see it when there's more than 2 points. But it's not way down by 100. It's not way down by the 60 and the 70. It's kind of somewhere in the middle of all of that. But kind of hard to show that when it's more than 2 points. So that's the same type of problem. That was number 4 through 6, either on the book problems or on that 1-page worksheet I gave you. Oh, then there was one more we did. Yeah, we got to do this one. So I went really fast on it in some classes, so I'll slow down and do it here in more detail. All right. So another kind of problem you're going to get is on what's called a coordinate plane. You just think of it as a graph. So you get this line on a graph, and they're going to say the same thing. We want you to put a point on this line and let me create some values about that. Let's see how that works out. Yeah, that's not too bad. So it would have, so this is like, I think number 7 and 8 on the book problems and that 1-page worksheet. So if we want to put a point on that line, and let's say the weights are, I'm going to do a different way because we haven't really done one like this. Let's say the problem tells you that the weight of A, it will just say this in the problem. Weight of A is 3. No. I'm just going to say it a different way. It won't. So the weight of A is 3 and the weight of B is 1. Sometimes it'll just tell you the weights. If that's the case, then you just use those weights. That's pretty straightforward. Don't overthink it. If they tell you what the weight is, that's the weight. So I'm going to say down here or up here, W equals 3. That's the weight. Same exact thing we did before when it was just a horizontal number line, a horizontal line segment. 1. Now here's the difference. You notice we don't have just a horizontal line segment with a number on the left endpoint and a number on the right endpoint. So what we said is, well, we may not have that, but we do have numbers for the point A and the point B. It's the coordinates. In the book pages, they actually give you the values, the coordinates, the X and the Y. Sometimes you might have to be able to figure it out. You may need to know how to find a point on a graph. So I need to know what is the X value for A, point A right here, and the Y value for point A. Well, I do that by going left and right to find my X. So I start at 0, 0. I go left. There I am. I'm at -4. So that's my X value. Now to find my Y value, I go down to get to the point. There's my Y value right here. That -2 is my Y value. You guys are really supposed to all know how to do that. I'm not going to spend any more time on it. So those will be the two values I wind up using for my calculations. So the weight is 3, the -4 and the -2 are the two values that I'll use. And I'll have to do it twice, once with -4, once with -2. And you'll see what I'm talking about in a minute. So now I need to do the same thing. What is the X and Y for 8? Again, I would go all the way from 0, 0 right here, all the way out to the X. Well, here's the X, 8. Then I go up to that. So my Y is 2. So again, that point, I'll write it to the side a little bit. 8, comma, 2, and I put parentheses. Right, now I got to clean this up a little bit. All right. Oh, don't need that. All right. So now that we put the points on there, again, they're already on there in the book. You won't have to do any of that in the problems I assigned from the book. Now I just do the exact same thing that I did before with those other problems where I circle and then multiply and add and divide. I'm just going to have to do it once with the X values for each endpoint and once with the Y values because I need an X and a Y to be able to put a point on this line. Like you need to know an X and a Y to put a point on a graph. There's no way to know exactly where it is if you don't have both of those. I'll use blue, I think, for the first one. So again, I'm going to circle. I'm circling the A, but just because it's in the way. Circle that. Circle that. Make sure you circle both of the X's when you do it the first time. So that means I'm going to multiply. I'm going to wind up erasing this, but I'm going to use this area right in the middle. So 3 times -4 is -12. I'm not going to write it all out. Hopefully you know. So what's in the circle is 3 times -4 plus 1 times 8, +8, divided by all of the weights added together. So here, here's the weights up here, 3 and 1. Now I just do the math. Well, looks like that's -4 on top, right? -12 plus 8, and then +4 on the bottom. So I come out with -1. Now, I want you to answer this question, pause it, whatever you got to do, because I'm not going to take a big long break. What is that -1? What in the world did I just do? So pause it. See if you can figure that out. Don't just keep listening. Truly try to think about what it is, unless you already know. Hopefully you figured that out. That is your X value of the coordinate that's going to go on the line. So I can go ahead and kind of write, this is going to be my answer over here. And I can go ahead and write in I know the X value for my answer is -1. Now, though, I got to go back. It's going to be a little tricky, probably, maybe not. Try to get rid of all this stuff. Yeah, kind of working. So give me a second. Yeah, I can go ahead and just erase now. All right. So we're going to do the same exact thing, but we have to find out what the Y value is now. Let's pick a cool color. Although my computer, it looks better on the screen in class than it does on the computer screen. But let's pick a bright green. Not really as bright as I would like, but that's fine. That should be pretty good. So I'm gonna circle the 3. Ah, I hate it when I do that. Oh, you know what? I could just do this probably. I'm gonna circle the weight again, but now I circled the Y value. Again, over here, circle the weight again, but now I circled the Y value. And now I just do the same exact calculation. Oh, I forgot to erase this. I don't really need that anymore since I wrote it over there. So I did green, so we'll do green again. So 3 times -2 is -6 plus 1 times 2 is just 2 divided by, and I add all the weights. Should always get the same value because the weights didn't change. 3 plus 1 is 4. So now I get -4. I got the same exact thing. -4 over +4. So I get -1 again. That is just a coincidence. That is not normally going to happen. What are the odds? So with that in mind, it's my point. That is where my point should be on the line if A is weighted 3 and B is weighted 1. Now here's the kind of nice thing about doing this on a coordinate plane. That point down here better be on the line. Like if I go to put a point on that somewhere on that line, locate a point on the line, then the point that I came up with better be on the line. If it's not, I did something wrong. So that right there, that -1, 1, if I go to put a point on the line and it's not on there, I did some math wrong. Now I can already see that I should be in good shape. So I go to -1, -1, and it is right there, right on the line, which is exactly what I said should happen. You should be on the line. And that is where the point falls if 3 is weighted, I'm sorry, if A is weighted 3 and B is weighted 1. Again, A is more important, so it pulls the midpoint. It pulls the point in that direction toward A. All right, so that was everything we did on locating a point on a line using weights. And then I assigned again those pages I already talked about. Next thing, last thing we did in class, and this one we really went fast on. All right, so we went to midpoints. That. Not that. There we go. All right, so I had that picture up and I flew through this in some classes. The recording might have actually got a little bit more in it. The class I recorded, I don't remember. So I'm going to take a little more time because this is its whole lesson on its own. It's a whole section of the next quiz on its own. We've already talked a little bit about a midpoint. So I'm going to go through everything, even the stuff we've already talked about. If they tell me, if the problem tells me C is the midpoint, that gives me a whole lot of information. I already know C is between A and B. I can just see that visually. So I know it's between it. So the very first lesson we did if you remember, I gave you a line kind of like that. And I said, what do you know has to be true? And eventually somebody initially said, oh, well, I know that, that's in the middle. Well, I told you, well, we don't know that yet. Just by seeing C between A and B, that doesn't mean it's in the middle. Might look like it is, but you don't know that. If they tell us it's the midpoint, that's what tells us it's exactly in the middle. There's also another way, and this is a big one here. This is called congruence marks, and you will see this in all kinds of lessons in geometry, these kind of marks. Oh, I didn't make them correctly. They'll just be these little lines on line segments or on the sides of figures. Those are called congruence marks. And what it tells you is that every line segment, every side of a shape that has the exact same number of little marks, so these both have one little mark, those are the same length. That's what that mark means. They are the same length without me telling you in any other way that they're the same length. So if you only saw what we're looking at, like ignore everything else, yeah, there we go. If that's all you saw right there, you would know C is the midpoint. That's a big conceptual thing. If you're not getting that, then you've got to just memorize it. If you see that and you know that AC is the same length as CB, C has to be the midpoint. Kind of the definition of midpoint. It creates two equal length segments. The red and the blue segments are the same length. Again, we'll do a lot more with congruence marks later, but I want to go ahead and introduce it. I'm going to get rid of them now. All right. So again, now let's say I tell you C is the midpoint. I just verbally, or not verbally, but in the problem, it just says C is the midpoint. So if C is the midpoint, I know I didn't want to do that. I know that AC, that represents AC, has to be the same length as CB. Again, that is the definition of midpoint. It creates two equal length smaller segments. But here's what's also true. I know that AC plus CB, and again, this is just little plus little is big. This is always true. AC plus CB has to equal AB. That's when I broke the pencil into two pieces in class. I said the two smaller segments added together would still have to equal the full length of the pencil. But I also know, I just said with this part right here, that red and blue line right there, that AC equals CB. So now there's a few ways to try to get this concept. So I'm going to try to cover all of them. So if this is the case over here, those two are, oh, and remember, I also said a while back, when we write something like with this kind of notation, then we've named the line segments. Not only are we naming them, but it really means the length of line segment AC, the length of line segment CB. We're typically going to be talking about the length of the segments, even though we're just writing it the way you see it with just two letters and the symbol above. So you got to remember that. The symbol above a line segment means the length of the line segment. The line segment. When we do proofs, there are some things where that's not true, but most of the time in the class, we're always talking about the measure of some shape or some object. Angles, the sides of figures, we're going to typically talk about the length of the sides. Transformations, that doesn't always apply really, but proofs and transformations is about it. All right. So if I know those two are equal, the lengths of them are equal, if I know that the length of AC, so I'm over here now, plus the length of CB equals the total length, I can do what's called substitution. You'll do a lot of this in proofs. If the length of AC and CB is the same, I could kind of say, well, wait a minute. Well, actually, let's use numbers. If I know that's 20 and that's 20, well, I could really use either 20. I could use the 20 on the left or the 20 on the right. They're the same, right? So it's the same thing down here. I could use AC or I could use CB if I'm talking about AC. So again, I know some of you are totally lost, but here's the punchline. I could actually say, well, if AC is the same thing as CB, I could actually write this equation like this. Because again, these are the same. So I could change it to CB and that would still be the same length because I'm talking about the length of these segments. So I just wrote CB, but that's the same length. So I still have the same equation, really. So that is a true equation. You could also say 2 times the length of CB equals AB. Adding it together twice is the same as multiplying. So that is a true equation. I could also say, well, wait a minute, can I kind of do the same thing? I could take this AC and replace that CB. Their lengths are the same. That's what this is saying. So I could go ahead and replace that. And I could say, okay, well, then that would mean AC, horrible C, plus AC. Again, the length of AC plus the length of AC again would be the same as the length of AB. So all of those statements are true statements right there. You could even do other stuff like say, well, if I took A, B, and I did not do these in class, if I took the entire segment and if I subtracted one of the smaller segments, I should have left over the other smaller segment. That's what would be left, right? I can show you that visually. Ooh, oh man, hold that thought. Oh, how can I show you this? Well, I'll just use numbers. So the total length of AB is 40. I can just add these two together, right? Total length of AB is 40, right? Well, if I take 40 and if I subtract one of the two segments, doesn't even really matter which one, I subtract 20, 40 subtract 20 is 20. I could have done it the other way. 40 subtract this 20 is 20. So there's all in this particular lesson, if you want to just put numbers in there to help you understand what equations could be correct, you can do that. You could make up your own numbers. You could put 20 and 20, 10 and 10, 5 and 5. If they're not asking you to solve for anything and it's just a concept, you could go ahead and do that. Just put two numbers that are the same if you know C is the midpoint, and then see if the equations would be true by plugging in all numbers into the equations and see if the equation works. Kind of like I just did. So again, if I want to know if this top equation is true, well, let me go back and show you my, didn't mean to do that. So I have 20 and 20, right? Well, I know AC is 20. I know CB is 20. And the only key is they have to be the same number if C is the midpoint. That's the only thing you need to be careful of. Well, yep, sure enough, that equals 40, which is what AB would be. Then I could do the next one. CB is 20. I'm going to do a highlighter. You should be able to see it through it. 20. CB again would be 20. Well, yeah, AB is 40. I know that. I can see AB is 40 right here. 20 plus 20 is 40. So that might be a way if you're struggling with concepts. Again, AC is 20, AC again is 20, and I already know AB is 40. Yes, those are true equations. So if you're struggling with the concepts, you could try to do that. A lot of times in conceptual math, that process will work if you're not actually trying to solve for something. I think that's everything. Oh, no, I'm sorry. No, it's not. So now there's one more thing you need to know how to do as far as just solving some problems. It's not stupid, super difficult, but I need to show it to you just to make sure. So again, this is based on the concept that C is the midpoint. So you would have to know that. Either they wrote congruence marks that told you that, or they just said C is the midpoint. So that's a short way to write midpoint. Somehow you would have to know C is the midpoint. As soon as you know C is the midpoint, wow, that means AC, the length of AC equals the length of CB. That's the first thing you should know. If you're setting reminders, like I've talked about, that's what you should write. If I don't know how you'd word it, but a midpoint or the definition of midpoint, or again, I want to find an app that you can actually set a reminder and have a picture pop up. It would mean that the left segment is the same length as the right segment. That's again, we'll have to come up with a way maybe to create that reminder, but that is the absolute number one thing you've got to know about midpoints. The blue segment equals the red segment. The length of the blue segment equals the length of the red segment. So I'm going to kind of, that will not totally be out of the way. So if that's the case, there are some problems in your packet. This is 13 through 15 in the packet that was stapled together, the 2 pages that were stapled. There's some problems where you have some numbers in there, something like this, or some expressions, I should say. Something like this. So I'm going to review a little bit. This is an X, by the way. First thing you have to remember, if you have not watched the other video about what is a variable relative to geometry, you need to watch that. Do it while you're watching this one or after you watch this one. This expression, that is the length of AC. It doesn't matter that it's not just one number, that there's a variable in it. That is the length of AC. We don't know what it is yet, what number it is, because we don't know what X is, but that is representing the length. And I would circle these if you're still confused. So you know every time you circle something, that is the length of that. This has nothing to do with what we did before when we did weighted average and we multiplied what's in the circle. We're circling this because it's the length. So if those are the lengths, well, we just said up here, I know that the length of AC equals the length of CB. So if I know those two lengths are equal, if I know that these two things are the lengths, then those two things have to be equal. So that's your equation. Oops. I would just say, okay, well, if I know those two things are the lengths and I know the lengths have to be equal, that's the equation you use right there. That gets you to a C, even if you can't do the algebra. And the algebra does get a little tougher in some of these because you have variables on both sides. I'm going to solve it out really quickly, just in case you're not sure how to do it. I would say, okay, I need all the X's to be in one group. I cannot just say, oh, well, I'll just add them together. So I'll just put 3X here. Because remember, the number one rule of solving, you have to remember this rule. You have to get this down. The number one rule of solving is whatever I do on one side, I do on the other side. So if I do plus 3X there, I have to do plus 3X there, and I didn't move X's anywhere. I still have X's on both sides. So if you make sure you remember that rule, there's a lot of mistakes it'll eliminate, like just combining the 3X and the 7X and the 10X. You cannot do that. You have to think about getting rid of the X's on one side. So I need to get rid of the 3X here. Now it's gone. It goes to 0. But again, whatever I do on one side, I need to do on the other side. And I would have 4X subtract 12 now. So the X's are now all in one group on one side. So now it's just a two-step equation. Hopefully you know how to do a two-step equation. We need to get x by itself. Oh, I messed up. So to get it by itself, I start with the 12. God, this pin is not doing a great thing. Not really a pin, but plus 12. Whatever I do on one side, I got to do on the other side. Last step, if that is 4 times x, which it is, I need to divide. So, or dividing that out, I'm going to leave it as the fraction 17/4. I would encourage you to learn how to use the fraction button on your calculators because most of the time, district stuff, I believe, and EOC stuff has a lot of fractions in it. So you need to learn how to use fractions. And you can just, like, you don't have to really understand what a fraction is, even just know how to use the button. So x would equal 17/4, or if you converted it, that would be 4.25 should be. But do not forget, and I didn't really have a question in this question, a question in the question, but go back up and read the question every time. That should just be an automatic trigger. Okay, I got the variable. Let me go read the question. And I wrote that up in the room. I'll try to remember to say it, but I'm at some point somebody's going to forget to go back and read the question and they're not going to answer the actual question. Make sure you go back up. Maybe they wanted to know how long segment AB was. They didn't even want to know the two little segments. We would have to say, okay, well, if X is 4.25, I would say 3 times 4.25 plus 5. So that would give me what the length of the blue line is, AC. That's what, 12.75. 12.75 plus 5, 17.75. So if they only wanted to know AC, I'd be done. I would actually also be done if they only wanted to know CB. I wouldn't need to plug it in also over here. I wouldn't need to plug it in there because I know AC is the same length as CB. Now, it might not be a bad idea to do it because if it doesn't come out to be the same, you did something wrong. So I'm still going to do it. A little trickier math. I don't have a calculator, so I'm just going to do it in my head. 7 times. Here, I'm going to get rid of some of this. All right, so 7. Again, x is 4.25. Subtract 12. Well, that'd be 28, 29. I think that's 29.75. Subtract 12. And sure enough, that does equal 17.75. So if I get the same number in both of them, I'm pretty sure I did it right. If they wanted to know what AB was, you would just add them together, multiply by 2, whatever you want to do. But make sure you go back and read the question after you solve for the variable. So that's a lot more detail on midpoints than we were able to do in class. You also got a little bit more on kind of the finishing problems for locating a point on a line using weighted averages. I'll post this as part 2 to the lesson that was on the 21st and the 22nd, since I'll be doing the exact same lesson tomorrow with my even groups.